Okay, so this is Oracle SQL Beginners, class 8 of 9. I don't need to read all that, people have seen all that before. As usual, I've copied a file from here. We're on subqueries and unions, so I'm going to drop that in there, copy that, and paste it in a window that I have open in SQL Developer for my user 35. There we go. I'll go back to the course notes. It's so sunny this morning I can't see the screen properly. And if I go forward to page 7, we're doing subqueries and union. We might do the advanced queries as well this morning. We'll see how we get on, because these ones were nicely 20 pages, but this one's a bit shorter. So if I jump there, so this section looks at what are called single and multiple row subqueries. A subquery is a query within a query. Also how to use the exist clause, how to use what's called an inline view, and how to use union, intersect and minus, joining two or more queries together. So the single row subquery starts with a premise. How do you find the product code, it says there, with the largest cost price? Okay, well, you can't do that and say give me the product description with a maximum cost, because if you don't use a group by, it doesn't work. We did that last time in functions. If you had a group by, however, and you group by something like product ID and description, it can't group because they're all different. So you still don't get the one with the biggest cost. Now I know that the one with the biggest cost is a laptop. There it is there. Actually, I've updated that. I think if you're looking at your data, it'll be a different cost. That's because I inadvertently updated my data last time. Tell you what, we can fix that. So I've got the same thing as you. If I go back to the data files, open, setup. If you remember, if you've updated the files, you want to put them back as they are, find the create file and run it as a script there for the user you want it for. And that refreshes the data by dropping the tables, recreating them and inserting all the rows. I could have done it with a backup, but this is an easy way to do it as any. When that's finished, I'll drop that. So I'm not going to update anything. Go back here now when I run this query again. That's better. There's the ThinkPad. It should have been 1093. Now I know it's 1093 and I can find the maximum cost like that. 1093. So if I know it's 1093, I could put 1093 in the select statement. Now that works, but it doesn't work if you update the cost, which is what I did actually. That's how it went up. Because what happens now is the biggest cost has gone up to 1202. So selecting 1093 doesn't give you the biggest cost. But because you can find the biggest cost like that, find the maximum cost per product, whatever it is, you can combine two queries together. You put a subquery in brackets within an outer query. Now that query returns 102.23. Sorry, 1202.3 is what I should have said. That is passed back into this select statement, and that will give you the biggest cost, whatever the cost is. And in fact, if I roll back what I just did and undo that update there, and then I run this again, I still get the biggest cost, even though it's a different value. and that's a single row subquery. It's a single row because if you use an equals here, you're only allowed to return one value. If that returns more than one value, it will fail. If it returns more than one value, there's exercises on this you can try, it becomes a multiple row subquery. And here's a simple multiple row subquery which uses not in. This is attempting to find supplier codes on the sale order table that are not in the supplier table. If you remember, if we look at the supplier table at its data, there's no supplier. It's not the data, it's the data. There's no supplier called COMP. But if you look at the orders, there is a supplier. So that's an invalid order for an invalid supplier. Now, if you wanted to find that, one way is say, find me the orders where the supplier code is not in and list all the suppliers. However, that's not all the suppliers, that's only some of them. And if you had hundreds of suppliers, you know, it would be an effort to list 100 there. In fact, the maximum for that is 1,000. You can't put more than 1,000 values in brackets there. So a better way to do it is to use a subquery. This subquery here, actually you can include the brackets with that as long as you get one at each end. Returns all the suppliers. So comp's not there. So if I run that query and then select order details where the supplier ID is not in that list, I should get comp, because comp is not there. And the difference between the two queries we've just done is that one uses an equals, so can only return one value. If you use an equals with multiple values like this, if I change that, I mean, it doesn't make sense, but illustrates a point. That will fail because it returns more than one value. So it says a single row subquery returns more than one row. So normally with multiples you use in or not in. Let's put it back how it was. There we go. Exists and not exist. Now, in some instances that's not the best way to do it, because if there are a lot of suppliers, thousands of suppliers, he has to run that query first, select all the suppliers, pass it back to this query. You can do it with a join, and this is what's called a correlated subquery, because there's a correlation between the inner select statement or the inner table and the outer table. Now what not exist does here, this says give me all the details for sale order where not exists, i.e. the supplier ID that you're selecting from supplier doesn't exist in that sale order table. To make sure you get the right one, you join the two tables together. So that one's called SO, this one's called SI, and you join them together, primary key to foreign key. And this is more efficient because where this one has to read all the supplier codes, this one does it the other way around. This one runs that query first and then sees if it can join it to the supplier ID it selects from this, well, yeah, from the supplier table, excuse me, with the join. You get the same result, you get the same results. And it's not any quicker here because we've only got a few rows in the tables, but you know, a big database, it would be more efficient. You might see this sort of query in data that you're looking at. You know, if you've been looking at databases already exist with lots of code that's already been hidden, you might see this sort of thing. Select X from supplier. The reason people do that is you don't really need the supplier ID, you just want to check if the join works. So you can just put a literal value. I mean, X is arbitrary, you can put anything in there as long as it's in single quotes, and you get the same answer. You can of course say exists rather than not exists, and that gives you all the ones that join, so all the other orders. So that's 3 ways of using subqueries. Here's another way. There's a lot of code here, but it's all in the file, so you'd have to type it in. This is looking at grouping ages by ranges. If you remember, we did this last time. So what that query returns is range ages for people. So there's their age, and there's the range that their age are in. Now that's a simple query. If you wanted to do something with that, like for instance find out how many there are within each group. So there are 2 people in the 64 range there, 3 there in the 44 range. You can do a group by like we did in the last class. Now one way of doing that, because that's lengthy, is to create a view based on that query. So that's exactly the same query, but I'm making a view called VEMPAge. Of course, having created a view, rather than typing that query in again, I can just select from the view. And that gives me exactly the same thing. But now we can manipulate the view to do a group by. We can say, give me the age group, which is the column heading I put on it there. So what we get here. And count how many there are in each age group from the view, putting the same thing in the select in the group by, and you get how many there are in each range, just like we did when we were doing group by. Now the point about this is you can use what's called on the left here an inline view. You don't need to create a view at all because it's wasteful really if you don't need it. So what you do is you code a subquery. You do the grouping, selecting age group and counting as a, so I've called it age here, and in the from clause, instead of putting the view, you put the actual code for the view down to there with its alias, age group, and then actually it goes all the way down to the brackets, doesn't it, there. So that effectively is your from clause. It's the same as the view. That will return the same results, but you don't have to create a view, and that's called an inline view. So there's the select there, there's the view created, and there's it used as an inline view. You can put a select statement in most places. It can go in, a sub-select statement, it can go in the select clause, it can go in the from clause, it can go in the where clause, the group clause. It's very flexible. And there are some more subqueries in the next section on advanced queries. Now leaving that for now, let's look at union. I think we mentioned this in the last section. A union you can use to join 2 or more queries together. So that query there gives me the product with the biggest cost. By using a sub-select, select the maximum cost is equal to. This query here gives me the maximum selling price. Now I can join the 2 together by putting the word union between them. And if you're going to union 2 selects, 2 or more selects, and you want an order by, the order by goes last. So my order by is there. And if I run that query, I get both rows. I get the cost and the cell. And I've done it and changed the headings because I don't want to say cost or cell. So I put type there. I've got cost in quotes there. Oh, I see. Oh, I see. Yes, I see. I just wanted some text which told me which was which. So that one's cost, that one's cell. So it puts the text in there and it puts a heading of type. And there's a heading, I've called that price because I don't want it to be cost or cell. And this unioned query takes its headings from the first select statement. Like I said, if you want an order by, you put an order by last. The rules with unions are same number of columns in each query and matching data types. So that's text, that's text, that's text, that's text. Those two are text, but these two are numeric, so they have to match. Here's an example of doing something silly with two different tables, showing how you have to match things. This looks at suppliers and finds the supplier ID. This looks at employees and finds the employee ID. This returns the supplier name. This returns the full employee name by concatenating together first name and last name, which we've done before. And the to char there converts because employee ID is a number, but supplier ID is character. So you have to have matching data types. And then when you run that, like it says, you've got the same number of columns, same data types. You get a list of suppliers there because they're character fields, combined with employees there, which are numeric fields. Like I say, it's not useful, but it shows you how you can join the two together. And again, little exercises. There are lots of little exercises in here for you to try for this. As well as union, you can say union with all, and you can say intersect and minus. And this illustrates the difference between these and what you might use them for. So let's do a simple union of the order ID on sale ord with the order ID on sale line. Now on sale ord you've got 11 rows and the order IDs go up from 100, 109 should be in there I suppose if they were in order, but they're not, up to 110. And then on sale line you've got the lines for each order. So there are multiple rows for some, but not all, of the orders. Now, if you union the two together, what you get is the orders that are on both. So those order numbers are on either one or the other. So we only get 11 because there are 11 on the sale order. If you do a union all, it gives you all rows whether they're in one or the other. So a union, they've got to be in this one and that one. A union all gives you a combination of the two. So you actually get 34 rows because there's 11 on one table, 23 on the other, combines them together and you get 34. Now that has its uses, but what is useful is if you do an intersect. Somebody asked this on a forum on one of the Oracle groups the other day. How do you find all the orders on sale ord that have got lines? Use an intersect. If it's in this table and this table, you get the rows. So these orders got rows, and you can check if you look at the sale line. So that's one. Go back to union again. Okay, hold on. Right. The union gives you what's in one, what's in the other combined together. So they're either in one or they're in the other. Yes, they're distinct values between the two, yes. A union all gives you duplicate values because they can be in one and the other. Yeah? And the intersect says they've got to be in the first table and the second table. So it gives you a way of finding orders with lines. So you pick up the order headers. Which of those have got lines? So it's 1, 3, 4, 5, 7 and 8. If you look at sale line, there you've got on 100 1, 3, 4, 5, 7 and 8. But on sale order you've also got 102, there's 3, 4, you've got 106, 5, 7 and 8 have got lines, but the others, including 110 and 19, haven't got lines. So to find the ones that haven't got lines, you do a minus. So that will show you what we've just run, shows you orders with lines. Minus shows you orders without lines. In the first one, but not in the second one. It's like, do you remember the outer joins we did when we were joining those nothing to join on? It's the same sort of thing. Okay? Yes, that's what you need to do, is go away and go and try it out. That's the way to do it. What have we got here? There's intersect, there's minus, and there are exercises looking at who's rented a film, who hasn't rented a film. You can try those. Now we did checking data, finding that order which has an invalid supplier comp by using outer joins, but there are other ways of doing it. You can do it this way with a subquery. What this does, that joins the two tables together and finds you all the orders that have got lines. No, sorry, valid suppliers. Sorry, valid suppliers. This query shows you orders which have got an invalid supplier. There's only one, isn't there? COMP. And you can do the whole thing. So back in the old days when Oracle didn't support outer joins, you would do this with a union like that. And there's the 109, which has a supplier which is not known. There's the outer join equivalent. If you remember, with Oracle you can put a plus sign there on one side or a plus sign there on the other side. And so if you're working on an old database, you might see that sort of code because they didn't support outer joins. But that gives you a full outer join because you get 109, which doesn't have a supplier, and you get gateway and orbit, which don't have any orders, if you remember. There's the outer join there. And then lastly, so that's a short section, that one. There are a few other things you might see in code, all, any and some, but they're the equivalent of using in fact. So bring that up to the top. Here you might see a query which says where supplier ID is not equal to less than, greater than, all of what's in there. So that will find you the missing supplier. But it's the same as saying not in, because if I put not in there, I get the same results. You can also use any or some, and they are the same as in. So there, if I said suppliers in, I get all the suppliers, sorry, all the orders with valid suppliers. And you could code that as equal to any of what's in there, or equal to sum of. Makes sense, I suppose, equal to any, equal to sum. But I mean, there's no need to use those, because, you know, you can use in instead of not in, but they're there for completeness. When you see exams, you know, sometimes things like this come up, so you need to know them. So that's the end of that section. There's a workshop. See, in the classroom we do these during the class. Sometimes they're optional, because if we did these during the classes it would make them much longer. So it's not going to work. When we do the PLSQL, I think we'll have to do the exercises outside the classes as well. So the next section is advanced queries. So we'll get rid of subqueries in union and say lord, and I'll empty that, close that, and go back to there, and this time I'll pull over, go on that one, the last one, example 6, which is the advanced SQL. There we go. What I'm going to do is, because I don't want to change that file, I'm going to copy it and paste, well, I'll change it if it's wrong, which probably won't be, paste it in there. Actually, it's out of order. I just thought it is out of order. I'll tell you what, I'll work on that one. Since it's out of order, I'll put it in order. Because I used to do it in a different order. Okay. So this section looks at how you can use the pseudo columns, they're called. They're not really there. You can't see them, but they are there. Like row number and row ID. How you can do what's called top N analysis, which is finding the top 5 rows. Which sounds easy, but it's not in older versions of Oracle. Correlated subqueries, so more on queries within queries and updates of those. And also it looks at hierarchical queries and master detail relationships. Also some of this stuff is at the end in an optional section. Can you hear that noise now? Yeah. Oh, just bear with me a minute. I'll shut the window. Then there'll be less noise because he's in the garden, I think. Let me just try to annoy us. There. Oh, that's a bit better. Yeah, it's a bit quieter. Right. Now, this top N analysis attempts to find the top set of values from a select statement, and you can do it using these pseudo columns, row ID and row num. There they are there. If I select from product, well, from any table, you can find the row number. So it numbers the rows when it selects them. And the row ID. The row ID is interesting because you can actually find a row in the table using that in the where clause. If I copy that up here, I can say where row num equals, put that in single quotes, You're right, that's why it's come up with an error. That's why it's come up with an error. Thank you. Can't get it all right, can we? Now it finds that row, and that is the quickest way of finding a row in a table if you know. Of course, usually you don't know the row ID, but Oracle uses it internally to find things, and that's the quickest way of finding the row. Now, where we might use this is here. Look here, if we select the products like that. Why did it drop to there? I didn't click on the sort. There we go. It numbers the rows. 1, 2, 3, 4. Now, suppose we want to find the rows, say, the top 5 highest selling prices. So what we could try and say order by cell, and we would get the top 5. So that's the biggest one. The ThinkPad. I forgot to roll it back again as well. Roll that back because I updated it. Remember? Put it back where it was. No. Oh, never mind. It doesn't matter. Sort that out later. But notice that the row numbers are the original row numbers before we sorted it. So what it does, it runs that select statement, numbers the rows 1, 2, 3, 4, 5, and then sorts them. What that means is you can't say give me the top 5 rows by saying where row number is less than or equal to 5, because that's not these 5 rows. That's the 5 rows that are numbered. Actually, it would help probably if there I put row num, wouldn't it? I'm just thinking. There. Right, those are the top 5 rows, 1, 2, 3, 4, 5, but they're not the top values. That's because it numbers the rows and then it sorts it into order. Now the way around that is to use a subselect. What you do is in a subselect you select what you want there, which is all the rows numbered, so those are the top 5 rows. But now when this select selects those rows, it renumbers them 1, 2, 3, 4, 5, and you can get the top 5 with less than or equal to 5, like that. Those are the top 5 rows. And that's how Oracle used to do top N analysis. Some databases like Microsoft, in there you can just put things like top 5 and it will give you the top 5. MySQL does that as well. Oracle have introduced a similar thing from 12C onwards, which won't work here because we're using 11G, but will work if anybody's downloaded the VM that I had running with 19C in it. If I just find those, we're on page 161, so we know we'll come back to. If we go home and we search for the string fetch, there we go. This is how you do it in 12C. You say select the rows just like I did there, but you add fetch the first 5 rows only. That will give you the first 5 rows, so you don't need a subselect, but only from 12C on. A lot of people are running 10G and 11G. You can also say, as well as fetch the first 5 rows only, you can say fetch the first rows with ties, which means equal values. So for instance here, if there were 2 for 610, you would get 2 values. And you can do it in percentages terms as well. Fetch the first 25% of rows. So I mean, if you want to try that, you'll need to have 12C or later running, and you can use the VM. Let's go back to 61. That didn't take me back to 161, did it? Never mind. That will. Okay with that? Yep. And there's an exercise there. Find the top 3 salaries from the employee table. Now back to correlated subqueries. There are some. I did this with the American group last Sunday. When we got to the end, one of the guys said there's some complicated subqueries there, and there are. But they're just examples to show you the sort of thing you can do. So, oh, actually, before we do that, I've missed something. There's another use of this. If you wanted to create test data and pick up, for instance, every 3rd row, you can do this sort of thing. So rather than finding the top 5, you can use mod, which returns a remainder, and say mod on the row number, which I put there with a RN, divided by 3. If the remainder is 0, then print the row. So you get rows 3, 6, 9, 12, 15, 18. If you wanted every 2nd row, change that to 2. And every 2nd row. So the guy who mentioned this on the course was using it to create test data based on the live data, but he didn't want every row. You know, he only wanted every, I can't remember, every 3rd row perhaps. Now this stuff is what has moved from here, because there's a lot of it, and I don't think that's that interesting to people unless you work in a council, which is where it came from. So I'm going to put that at the end somewhere. Oh, come on, it can't go down that far. Go down as it does. What's all that? Oh, there's other stuff, isn't it? Just bear with me a minute. I'll just post it. I'll just paste it in there. Okay, and we'll go back to the top and then come down. Right, so in the notes, the next bit is these correlated subqueries, and these are examples of how you can put a subquery in a select statement, or we've seen ones in a where clause. There's another one in a where clause. This one lists the highest paid employee for each manager. So you've got you've got the manager, which is a code, first name and the salary as maximum salary from the employee, where the salary is equal to the maximum salary from employees, but then you have to join the table back to itself, joining the employee to the manager, so you get the highest paid employee for each manager. And then I order it by 1, 2, 3. So she is the top paid employee for manager 1, etc. 2, 3, 4, 5, 6, like that. And this one's similar. This lists employees, their manager and salary, and the highest salary for those employees. So again, you're getting the first name, the manager and the salary, and selecting the maximum salary from that employee, again joining the inner table to the outer table, which in this case is the same table, because you can join tables back to themselves. And if you remember, Abby had the maximum salary for her group. So Steve's salary is that, but the maximum salary for group 1 is that. Maximum salary for group 2 is that. It's funny the things people ask you to produce when you're working with customers. This is one which I like. This finds you a list of all product lines. If you remember, a product line is the first 2 characters of the product code. So they are disk drives, That's a book. That's a keyboard. It's another keyboard. Now what we want to find is a list of product lines with a greater than average margin for their product line. So you need the average margin for a book, and then which books sell for more than the average margin. Now the way you go about that is you build it up. Hang on, what's happened here? Oh, I'm sorry, I'm in the wrong file. It should be there. Don't want that file. No. Here we are. So this sort of thing we did, or if you did the exercise solution, this is a solution to one of the exercises. This gives you the first two characters of the product, which is the product line, and the rounded average margin, and groups by first two characters of product line. So what you get back is the average margin for each product line, 12 rows. Now you can move on and say, to find products which have a greater than the average margin, this query here is the same as that one, just the average selling price. That's not the same, is it? I'll take that back. No, it's not. Forget I said that. Also it should say greater than now, because you can do less than as well. Okay, this that's going to appear again in a minute. So here we get the product and the margin from the product where sell minus cost, because you can't use margin in a where clause, an alias, you have to repeat that, is greater than the average sell minus cost from the product, joining the first two characters, the inner table, first two characters, the outer table. And that gives you the ones that have a greater than average margin. Now you can check it if you look at BK2 and we go back and run that one. BK was 4.61 and BK2 is greater than 4.61. In fact, if we did less than, that's not less than, we go, BK1 is less than the average. Now what I usually do, because I want to see both, I want to see which ones are less than or greater than, depending on what you put there, and the average as well. I union the two together. So I do this query here. This gives me the average margin grouped by, which is those 12 rows, and I union it with the query we've just done and order it by the first column. So what you get is that the average for BK is 4.61 and BK2 is greater than the average. CO's only got one row, so the average, and there isn't one greater than the average. There's DR1, which is greater than. In fact, if we change that to less than, just to see it changes. Yes, that's because we go back to the data. There is only one CA product, so the average is equal. If we do equal there, there's CA. CA is equal because there's only one product, so the average, matches the average for that product. And there's CA1. See, they're the same because there's only one product. So when you find the average for the product, it's the same because there's only one product. Let me change that back to greater than. Now if you want an exercise on this, there's one. It says list the average cost of a film by category ID, because on the film table you've got films. Whoops, I'm there. Oh, I clicked too high. You've got films here. There's, sorry? Yeah, there's the category ID there. So you can find the average cost of a film by category ID and then find all films with a greater than average cost for their category ID. Now, that's a correlated query. What's fun that you can do is you can do correlated updates, which I like. And here's an example of that. If you remember the last section or the one before when we did flashback update, I showed you that that order number is for the 2nd of February and that if I update it, it's now for today. But I can of course roll it back rather than committing it by typing rollback, and now it's gone back to where it was. But if I update it, commit it, it's changed to today and I can't roll it back. But what you can do if you made a mistake like that is you can look at it as it was 5 minutes ago there and say select from sale as of timestamp today's date and time minus an interval of 5 minutes. So 5 minutes ago 1:08 looked like that, 2nd of February, and yeah, that's right, that's what we did. So you could look at it 5 minutes ago. Now let's make a complete mess of the table and update all the dates to today. Commit the change. Like I said, I can't roll it back. It's done. They're all for today. But what you can do is you can do a correlated update. You can say update sale order, set the date order equal to, select the date order from sale order as of 5 minutes ago, joining the inner table to the outer table on order ID. It's a sneaky one, this, because you don't put the table alias there after the table name. It has to go there after the as of clause. And what that will do is update them all, set them back as they were. And if I select from sale order, we know that 1:08 will be the 3rd of October there, and the others have all been reset as they were. Got another example of that actually that I quite like. In the create files, if you look at employee, this drops the table employee and department and then recreates them. So if I run that will just drop the tables and recreate them. Okay, and then I change the current date format temporarily, which you can do with an alter session statement. So it was day, month, year, and I inserted all the employees with dates in that order, say birthday. but they need an email address. Now, rather than typing email addresses in for them all, what I did, I just called them all email. So we ran down to there. That puts all the employees back. Of course, the problem now is if I look at the employee table and I look at the data, all the email addresses just say email. Now to fix that, you do a correlated update. Whoops, it's the wrong one. Ignoring the greened out bits. There we go. So to make their email addresses, I altered the dates back to the default, which is day, month, year, and then I update the employees. This is E1, setting the email equal to and selecting first name concatenated with last name, like that, replacing any spaces. So I think one of them had a space in the name with nothing, and concatenating it with @FBT, which is my company, flyingbridgetraining.co.uk. Now that comes from the same table, the employee table, but the trick of course is the joining. Join the outer version of the table to the inner version on empid, and what that does is updates all the rows. And then if we go back and look at the employee table and refresh the data, there are the email addresses. So it joined them. The reason I replaced the space was Colin A and Colin P have got spaces in their first name. So it didn't work. But that just concatenates it. I thought that was really neat. And then I put department table back. In case I made a hash of things, what I'm going to do is just rerun the whole thing, which will refresh both tables, because I dropped the department table. There we go. And you can do that if you're messing about with the tables and you change any of them. Employer and department are in that one. The film tables, rental, film, where are we? Rental, film and member are in create film, and create order has supplier, sale order, sale line and product. So you can just refresh the data by running those files. So where are we? Joining tables to themselves. Okay. There we are, a self-join. If we look at the employee table, yeah, at the data, people have a manager. So he's managed by employee 3, which is Jan, who is managed by employee 2, which is Alan. Alan's a top man. He manages Jan, Chloe and Daisy. They manage well, Jan manages that one, that one, that one. Chloe, who's 4, manages that one, that one, that one. Now suppose we want a list that says John is managed by Jan. Jan is managed by Alan. Chloe is managed by Alan. You can do that by joining the table back to itself. We've seen some joins tables back to themselves in the subqueries, but you can do it like this. Let's have a look at, I mean, that's just the list. So that's who manages who, but what we want there is a name, not a number. Now you can go about that by doing a query with both tables. Both tables, well, it's the same table, but the same table two times. That's the employee version of a table, called E. That's the manager version of a table, called M. So we want the employee ID from the employee version and their name, but we want the manager from the manager version with their name. Now that doesn't work. That gives you a correlated query because it joins everything to everybody else. So John manages himself and he's managed by everyone else. That's no good. You've got to put a join in. Now the join in here, I will change these joins actually to work the other way, because most people prefer join and on, don't they? So if I change that to say join and I change that to say on, you get the same thing, but people are more, well, they're happier with that format. And there you get it. John is managed by Jan, Jan is managed by Alan, Chloe is managed by Alan, just by joining the two tables together. But what you can do with this, yeah, which is really neat, is you can do what are called hierarchical queries, and you can get a tree structure. Here's a simple hierarchical query here. Actually, I think that's the same query as that one, isn't it? That is the same query, but doing it the other way, which is a bit daft. If you do a hierarchy, you can use things like, within your select statement, like level. So things have different levels within a hierarchy. You can use start with, telling it where to start, and connect by. Now here's a simple example here. Well, you select from the employee table, start with employee 3, which is Alan, the manager, and connect by prior employee ID equals manager. So you're going from the employee ID here back to the manager, starting at 3. Actually, it's not Alan, is it? Jan is 3. And what you get is a hierarchical query like that. John is managed by. Again, you're not getting names there, but we can put names there in a minute. This one starts with the top level, Alan, and does the same sort of thing. So you can see who manages who. I prefer it with names like that, but to get names here, to get oh, actually there's more stuff in here you need to know. Here you can eliminate Jan from the list if you want to. Is that one? There's too many examples in here, to be honest. The interesting stuff's further on. Let's go on to the interesting stuff. Let's look at levels. Levels is where the fun begins, if you want to do this sort of thing. If you read through them, there's a lot of theory there, but let me show you how I like to do it. This one here, not that one, this one. What I'm doing here is I'm finding the first name, and then I'm padding out the first name to 40 characters with underscores, so it's padded like that. And what I'm going to try and produce is a tree-like structure. I'll try, and I'm going to produce it, because what you can do is do this. So what you do is you get the first name, the length of the first name, which is 4. So that's 4 characters, 3 characters, 4 characters. And then what you do, you use the levels. So he's at level 1, he's at level 2, at level 3, etc. And then you take the length of the first name. So for Alan it's 4, plus the level times 2, well he's level 1, so 2 times 2 is 1, minus 2. sorry, 1 times 2 is 2 minus 2, so you get no underscores. Now if he's the next level, which is 3, 3 times 2 is 6, minus 2 is 4, so they get underscores. That's the idea. The idea the underscores build up depending on what the level is. And what you're aiming for is this sort of thing. Taking out, because you don't need to know the length and the level, that was just to illustrate how it works. A query like that, which is really nice. So Alan manages Jan, who manages John, who manages Abby. Jan also manages Steve, Colin, Stephen and Darcy. And then Chloe manages these people. And Daisy manages those. And Fred and Colin are managed by Alan. I think that's really neat. Because he's the top man. You see, the way you get rid of the underscores, that's right, he's not being managed by anybody. So when you do his calculation there, here's his level. If we go, see, the reason I put level and length is you can't see level and length in this one. But if you put level and length in, I pinched all this off the internet somewhere and just amended it all for my data. See, his name is Alan, it's a length of 4, and then you add to that level times 2. Well, he's level 1. 2 2s are no, hang on, he's level 1. 1 times 2 is 2, minus 2 is 0, so he gets 0 underscores. That's how it works. And then when you go down 1, you know, they get an underscore, get 2 underscores, get 3 underscores in order to push it out. It's clever stuff, but you know, it's only any use if you've got a hierarchical table where something links to something else. Like another example of it is in manufacturing, when something is made up of components, you can find, you know, the finished product and work out which components it's made from, which is quite neat. They're all the examples in the notes there, but they're all in this this text file. The other thing in here that I moved to the back, actually I moved that to the back as well, although I think that's interesting. Give me a minute, I'll get back where we are. I mean, some of this stuff is just mind-boggling, I suppose. Right, there's the group stuff, which is in the notes there. And if I go down, I'll just paste this lot back after groups. That's what we're doing there. And ranks, we'll put this there. Right, now the reason this is in the self-study is not a lot of people are interested in this. And I did this stuff on grouping for a council who were very interested in when people were born, because they had to work out pensions and that sort of thing. So they were interested in grouping by. So what I did here, I mean, I'll leave you to test this yourself. It works though. They created a dummy table, populated the table with some data, displayed the table. It was called Works Clock because people had to clock in at work. And then you grouped by year, counting how many people had logged in or clocked in. And you can do it by year, by numeric month. There are loads of examples. By character month properly, like January, February, March. By day, by hour. There are loads of examples there. By time interval, you know, by every 15 minutes, for instance. 15 minutes is quarters. By minute interval. But I wasn't going to go through all that because it's, you know, most people, it's too much. There was one other thing here that was interesting actually, and that was ranking. And master detail relationships. Have a quick look at those. Ranking, I mean, I've not looked into this, but there are lots of other functions that you can use if you're doing data analysis, and this is a simple one. We did that query earlier to find the top 5, and you notice that one's 822. What you can do and say things like, where does that rank, where does 823, the value 823, rank within a group? I haven't got very good examples of this, but it's the third one. That's not a very good example at all, really, is it? That should be, if anything, that should be H22.13, like that. This is the third in the group, but if you're interested, there's loads of stuff on the internet on how to use these things. What I thought was more interesting was this. You know, we can find a table like supplier, and we can draw a data model by simply clicking on model. Clicking on model. I'm clicking on it. There we go. And the data model shows you the master detail relationships, the master table, detail, parent and child. So supplier links to sale order. Now, if you're using an environment like SQL Plus, SQL 99 it must have been, like this, you've got no GUI, so how do you find your master detail relationships in here? And the answer is you look in the data dictionary. Data dictionary, which is a set of tables which are always there, begin things like user, all, or DBA, most of them. You can interrogate your tables and find, for instance, your foreign keys. I know the foreign keys because I name them all FK, a foreign key. An R is a referential, so it's a reference, a foreign key. Primary keys have a P there. Let's move this over. Now what this does, this finds the master table, that's the one end, to the detail table. I mean, people often call these things parent and child. Well, here I've called it master detail. From user constraints, named P, same table named F, where the constraint type is P, so we're picking up primary key, but we're joining the constraint name on one to the constraint name on the other, and what you get is that film is the master of rental, member is the master of rental as well, so the one-to-many there. There's supplier to sale order, there's sale order to sale line, product to sale line. So that's how the tables link together. Now you can get much more detail if you flesh it out like this. Again, it's tables joining back to themselves mainly. So film, which has this primary key, the primary key column is film ID, links to rental, and the rental key column is, well, the foreign key column is film ID. In the real world, those column names might not be the same, so this sort of thing is useful for finding out what you've got. I just thought I'd include it because it's a use or an example of tables joining back to themselves. There it is in the notes there. And like I said, if you look online, there are lots of examples like this online. Right, and that's the end of this class. Next class will be SQL Plus command line, which you won't have unless you install it on your laptop, although you can get it in the VM, which runs 19C, and also if you want to do export and import, which is the last bit somewhere here, you won't have that probably unless you've installed it on your laptop. You can probably find an Oracle client to download with that in, or use a virtual machine. That's the best way. And that's the end of this class. Next one will be class 9 of 9, the last one. Okay, thank you and goodbye.